Today, we're diving into a new study focusing on the Pfizer COVID-19 vaccine. This particular research delves into an area that might not be immediately obvious: the potential effects of the vaccine beyond the commonly discussed side effects. We aim to unpack the details and shed light on what this study reveals. Specifically, we'll be examining its potential effects on the eye, with a focus on the cornea, the clear front surface that plays a crucial role in vision. The cornea is the eye's outermost lens, and its health is paramount for clear sight. Science is always evolving, constantly refining our understanding of the world around us. New studies emerge regularly, building upon previous knowledge and sometimes challenging existing assumptions. And this research, like all scientific endeavors, helps us better understand how vaccines interact with our bodies, triggering immune responses and potentially influencing various physiological systems. It's all about gaining a more complete picture. A dedicated team of researchers in Turkey has recently provided the first detailed look at subtle corneal changes observed after vaccination with the Pfizer COVID-19 vaccine. Their work offers valuable insights into this specific area. It's important to emphasize that for most people, these changes are minor, subtle, and very unlikely to have any noticeable or lasting effect on their vision. The vast majority will experience no visual disturbances whatsoever. However, for those with pre-existing eye conditions, such as dry eye syndrome, glaucoma, or other corneal issues, or individuals with a history of eye surgery, including LASIK or cataract removal, this information could be especially relevant and worth discussing with their eye care professional. The primary goal here is to inform and educate, not to cause alarm or undue anxiety. We want to present the facts in a clear and balanced manner. Our aim is to empower you with knowledge, enabling you to have informed conversations with your healthcare providers and make the best possible health decisions for your individual circumstances. To provide context, we'll break down what the cornea is, explaining its structure and function within the eye. We'll also discuss why it matters so much for maintaining clear vision and overall eye health. Finally, we'll delve into the specifics of what the study actually found, examining the data and conclusions reached by the researchers. It's crucial to remember that a statistically significant finding in a research study doesn't automatically translate into a real-world problem or concern for the majority of people. Statistical significance simply indicates that the observed effect is unlikely to have occurred by chance. The Pfizer vaccine remains a crucial and highly effective tool in our ongoing efforts to combat the spread and severity of COVID-19. And this type of research is an integral part of the ongoing efforts to continuously monitor and ensure the long-term safety and efficacy of all vaccines. So, let's explore in more detail what this study means for you, your eye health, and how to interpret the findings in a responsible and informed way. To understand the study and its implications, we need to delve into the intricate workings of the eye. It's crucial to grasp the function of each component to appreciate the research fully. Let's talk about the cornea, a vital part of your eye that often goes unnoticed until there's a problem. The cornea is the clear, dome-shaped front window of your eye, acting as the first point of contact for light entering your eye. Think of it as the eye's protective shield and primary focusing element. Its job is to bend light and help you see clearly, focusing the light rays onto the retina at the back of your eye. This bending, or refraction, is essential for sharp vision. So any change in its shape or clarity, even a slight irregularity, can significantly affect vision, leading to blurriness, distortion, or other visual disturbances. The innermost layer, the endothelium, is a single layer of cells that plays a critical role in maintaining corneal clarity. This endothelium is made of specialized cells that pump out excess fluid from the cornea, preventing it from becoming waterlogged. By pumping out fluid, the endothelium is keeping the cornea thin and transparent, allowing light to pass through unimpeded for clear vision. If these cells don't work properly, if their function is compromised, the consequences can be significant. Then fluid builds up within the cornea, saturating the tissue and disrupting its structure. This fluid accumulation causes swelling and cloudy vision, a noticeable decline in visual acuity. This condition, where the cornea becomes swollen and opaque due to fluid retention, is called corneal edema. Unlike other cells in the body, endothelial cells don't regenerate or multiply to replace damaged ones. They are irreplaceable. You're born with a finite set number of these cells, and that number slowly decreases throughout your life due to natural aging and other factors. If too many are lost, If the cell density drops below a critical threshold, the cornea's ability to regulate fluid balance is compromised. As a result, the cornea can swell permanently, leading to chronic discomfort and significant vision impairment. In severe cases of endothelial cell loss and persistent corneal edema, the only viable treatment option is sometimes requiring a corneal transplant to restore vision. To monitor the health of the endothelium, doctors measure these cells' characteristics using specialized equipment. They carefully assess their number or density to determine if there's been any significant cell loss. Beyond just the number, doctors also analyze the cell's size and shape to assess overall corneal health and identify any signs of dysfunction. This assessment is especially important before eye surgery, as certain procedures can further impact endothelial cell health. Healthy endothelial cells are typically small, indicating efficient function and proper fluid regulation. They also exhibit a uniform size and distribution, creating a consistent and effective barrier. Ideally, these cells are hexagonal, like a honeycomb, fitting together perfectly to maximize coverage and efficiency. Any deviation from this regular pattern, such as variations in cell size or shape, signals stress or damage to the endothelium. That's why even subtle changes in these cells matter and can provide valuable insights into the overall health and function of the cornea. The Turkish study followed 40 healthy volunteers with no eye diseases or surgeries. Each participant had a detailed eye exam before their first Pfizer vaccine dose, using advanced imaging to measure corneal thickness and endothelial cell health. After 2 vaccine doses, participants returned for a follow-up exam about a month later. The same high-tech machines measured their corneas again, allowing for a direct before and after comparison. This careful approach ensured any changes were likely linked to the vaccine, not other factors. The study focused on cell count, cell shape, and corneal thickness. By establishing a clear baseline, researchers could spot even subtle shifts. This method provided reliable data on how the vaccine might affect the cornea. The study found a small but significant increase in corneal thickness after vaccination. There was also a slight drop in endothelial cell density, meaning fewer of those crucial pump cells. The remaining cells showed more variation in size and shape, with fewer maintaining the ideal hexagonal pattern. These changes suggest mild stress or inflammation in the cornea, but they were only detectable with sensitive instruments. Importantly, none of the participants noticed any vision changes or discomfort. The findings were subclinical, meaning no symptoms, just microscopic shifts. For healthy eyes, these changes are unlikely to cause problems. Still, the results highlight the need for ongoing research, especially for those with existing eye issues. For most people, these microscopic changes mean little. Your cornea has a healthy reserve of cells, and minor losses won't affect vision. However, people with pre-existing corneal conditions like Fuchs's dystrophy or those planning eye surgery should take note. In these cases, even small cell losses could matter, especially if the cornea is already compromised. Eye surgeons may use this information to better plan procedures and monitor at-risk patients. For corneal transplant recipients, a vaccine-triggered immune response could theoretically increase the risk of graft rejection, so closer monitoring is wise. The study didn't include transplant patients, but its findings suggest extra caution for these groups. Overall, the research helps doctors personalize care for those with vulnerable eyes. Let's look at the numbers. Corneal thickness increased by about 1.2%, from 545.3 to 551.7 micrometers. Endothelial cell density dropped by 4.4%, but all participants stayed within the healthy range. The variation in cell size increased, and the percentage of ideal hexagonal cells dropped slightly. These changes were consistent across the group, not random. For context, vision problems usually don't occur until cell counts are much lower. The data shows a subtle, measurable response in the cornea after vaccination. These findings move the conversation from speculation to evidence. They also highlight the importance of tracking even small physiological changes. More research will clarify if these shifts have any long-term impact. The study only looked at changes 1 month after vaccination, so we don't know if these effects are temporary or permanent. The likely cause is a short-term immune response, which may resolve as inflammation subsides. However, since endothelial cells don't regenerate, any loss could be lasting. For healthy people, a small one-time reduction probably won't matter. But repeated doses or boosters could have a cumulative effect, something future research must address. long-term studies are needed to see if corneal health returns to normal or if changes persist. Until then, we have a well-documented short-term observation and some important unanswered questions. This uncertainty is why ongoing research is crucial. Tracking participants over months or years will provide clearer answers. For now, the findings are a starting point for further investigation. Medical advice hasn't changed. COVID-19 vaccination remains strongly recommended for the general public. The benefits far outweigh the small subclinical corneal changes seen in this study. For people with corneal disease or transplants, talk to your eye doctor before vaccination. Establishing a baseline and scheduling follow-up exams can help catch any changes early. If you notice new eye symptoms after vaccination, see an eye care professional promptly. Open communication with your doctor is key to protecting your vision. Monitoring at-risk patients more closely is a sensible precaution. For most, vaccination continues to be safe and essential. In summary, after thoroughly examining the data and considering the broader context of vaccine research, we can draw some important conclusions. This study adds a new layer to our understanding of the intricate relationship between vaccines and potential, albeit rare, side effects. It provides valuable insights into the specific corneal changes observed. This contributes significantly to our overall understanding of vaccine safety, reinforcing the importance of continuous monitoring and vigilance. The Pfizer vaccine remains a vital tool in our ongoing fight against COVID-19, offering substantial protection against severe illness and hospitalization. Importantly, the corneal changes observed in this study were minor, transient, and symptom-free, indicating they did not cause any significant discomfort or vision impairment. Therefore, for most people, these findings should not be a cause for concern, as the benefits of vaccination far outweigh the minimal risks. However, individuals with pre-existing eye conditions or a history of corneal issues should use this information as a valuable resource to guide informed conversations with their doctors, ensuring personalized and appropriate care. The study also serves as a testament to the effectiveness of our current safety monitoring systems, demonstrating that they are working diligently to identify and assess even the most subtle effects associated with vaccines. This proactive approach allows us to catch even subtle effects early on, enabling timely investigation and informed decision-making. Of course, more research is needed to fully elucidate the long-term implications and potential mechanisms behind these observations. This includes especially long-term studies that follow participants over extended periods, as well as larger, more diverse groups that accurately represent the global population. Science is a continuous process of discovery and refinement, constantly evolving as new evidence emerges. This study is just one step in refining our knowledge, contributing to a growing body of evidence that informs our understanding of vaccine safety and efficacy. It's crucial to stay informed about the latest scientific findings, ask questions to healthcare professionals, and make health decisions based on the best available evidence in consultation with your doctor. Vaccines continue to protect millions of people worldwide from serious diseases, preventing countless hospitalizations and saving lives. Ongoing research and rigorous safety monitoring ensures they remain as safe and effective as possible, minimizing potential risks and maximizing public health benefits. Ultimately, your eye health and your overall health are interconnected and equally important. Both are best served by staying engaged in your healthcare, proactively seeking information, and maintaining